Okay, good morning everyone. So welcome to our CWS seminar today. So today we have Sun Yan Evans from Mott MacDonald. So she's a Mott MacDonald Fellow and a Technical Director, and she's been working with the company for 20 plus years. And
26 years plus.
Yeah, and also working in the industry for 35 years. Very extensive knowledge and experience on this water industrial area. So we have our pleasure to having her to give us a talk today. So welcome.
Thank you. Hi, good morning everyone. And as Oak said, my name is Sun Yan Evans. I am from Mott MacDonald. And for those people who do not know Mott MacDonald, so Mott MacDonald is a global consultancy company and headquartered in London. And we have 20,000 staff and across the globe. So in the company, my role is a Mott MacDonald Fellow and Technical Director. So everybody in the company call me Sun Yan. So you can call me Sun Yan. I think it's a true privilege here today to be here in the Exeter University. So I used to come here a lot when I'm doing the work for the Environment Agency. So today, the topic I'm going to cover called harnessing global water wisdom and the lessons for the future. I often use the quote, the water engineering in many senses is about turning the seemingly impossible into the possible. So I'm going to, based on my own personal experience, and share with you some of the insight and stories across the water sector, and to demonstrate how the impossibles were achieved. So in my career, I have the privilege worked on over 250 projects across more than 20 countries. So in this session, I'm going to share with you 6 projects and extract values and share my learnings and from those projects with you. So our journey and will cover diversity, flood risk, water quality, water resources, and water supply. So let's begin our journey, first of all, about the diversity and in Africa, and then move on to talk about the national reservoir inundation mapping in the UK. From there, we are going to talk about coastal flood risk along the east coast, then followed by river water quality to enhance water quality in Wales, and then talk about briefly developing the water pollution reduction performance guideline for the Water UK. And lastly, to share you with the story, particularly about water supply in Shanghai. So let's begin our journey in Chad and Chad and Cameroon. That's in Africa. So what happened was that in the 1970s, and I think here, particularly apart from these professors, some senior colleagues here, maybe a lot of you not born. That's in the 1970s. That's in Cameroon, they started called a SAMRE scheme, that initiative. So the SAMRE scheme, SAMRE stands for Society for the Enhancement and Modernization of the Rice in Yagawa. So where's Yagawa is located in the northern Cameroon on the border with the Chad. And from the slides, you can see the location of the Lake Chad. So that initiative, what's the aim for that? So the aim is very clear. It's basically to ensure to boost the food security and also particularly enhance the economy in the northern Cameroon. So that scheme itself has 3 pronounced objectives. And first objective is to build agricultural productivity. And the second objective is to implement water management effectively and in Cameroon. So That involves building the Lake Magua, what you see in front of you on the slide, and also build the dikes along the river called River Lagoon. That's the river flows into the Lake Chad. And the third objective, basically, to improve the farmer's livelihood. So in that way, to increase the yield of the rice, at the same time, also to enable a double crop. So therefore, to improve the farmer's income. So what's the outcome of this initiative? So the outcomes is this. Local farmers really enjoy it. And enjoy what? The yield of rice significantly increased. And the local community, they're so pleased and delighted. Why they are delighted? Because they're able to enjoy the local rice produced locally, and the school children be able to enjoy the fragrant rice in the school. Now think about it. This initiative, initiated in 1970s, with the objective, have they achieved it? That outcome. Now, the question I ask you to reflect is, how do you feel about this initiative? Aren't they remarkable? Farmers delighted, children delighted, local community delighted. So let me carry on with the story as time moves on. So before they built the rice scheme, the summer rice scheme, and the people could do the fishing, not only river, also on the floodplain, because the seasonal flooding, they can bring the fish, and the people can catch a fish from the seasonal flooding. That's become a really important nutrient and protein for themselves and for their family as well. However, after they built the flood scheme, built this rice scheme, they built the Lake Maga, and they built the dike. They cut off the flooding on the floodplain. The floodplain is enormous. You're talking about 30, 40, 50 kilometers wide. And also, if you see on the slides here, there's also called Waza National Park. Beautiful wildlife there, so I had the privilege to visit there. So the flood also cut off the water, get there as well. What's led to before, and so the elephant could enjoy the water because of the seasonal flooding. Now there's no water can get to them. They start to move towards the waterfront. So therefore, the ecology be damaged and further downstream. And they also caused conflict between the wildlife and the humans. And also in the past, before the summary scheme, and people be able to easily catch fish, put the basket in the field, in the morning, in the evening, in the morning they can have fish, take home and to cook for their family. So their basic livelihood be affected further downstream. And what else? And the consequences become socio-economic and really pronounced. So what's happened to this situation to the wildlife park? So what they start to do is basically use tankers to transfer the water and to the national park. If you've been to Africa, to that part of the world, you will know the evaporation rate, acidity rate, is absolutely huge. The water hole can't be very deep, and they evaporate so fast. So this solution simply is not sustainable. So in the year 2000, so we've been commissioned by the European Union. That's Mott MacDonald being commissioned by European Union to find a solution. How can we reverse the damage caused by further downstream? So I was the technical lead. So I visited the site and flew to Chad and went to Cameroon. So that's me on the boat. Took the picture of the boatman who drive me through this river system. You can see the vegetation system, how fast we grew. Sometimes we learn it in the classroom, if not with site experience, we simply don't know. And the real world, what it really look like. It's very educational to me. When I went on site, and there's some lot of cages being built, and it's there not being used. I said, what the cage is for? So this is from Netherlands, sent by them here for the student to measure the vegetation growth and what's happened to it. And when they come to measure just the vegetation just shooting through the cage, they build meter by meter by meter. So the speed of the growth in one season is much higher than me. So you can't really see me. It's good place even to the height. So now I've been taking the lead to do the job. So what I have done, I visited the site also and interviewed local communities as well as the Waza National Park staff to see what's the problems and what they wish to achieve and how can we long-lasting and happiness for everybody in the catchment. So at the end, we decided also to do the monitoring and understand how the water moves in the river system from upstream to downstream, and we built a hydrodynamic model. So for all of you, particularly students sitting here, how important is studying water engineering? So we'll be able to build a model that's become really, really powerful tool, be able to cover 300 kilometers and 50 kilometer wide. And that model not only simulates the water flowing, also simulated the evaporation and seepage, because that is, if you don't consider, you don't get the right result. So we come up with a solution. What was the solution? It's called managed release through the dikes. So in that case, we not only secure the water supply for the rice upstream, and also ensure the seasonal flooding get under the floodplain, get into the Waza National Park, so the animal can really enjoy as well. And also the seasonal flooding be able to bring the fertile soil onto the floodplain. So farmers is a free resource rather than fertilizer. It's natural soil. It's full of nutrient. They can grow crop and feed their family. So you wouldn't believe when you witness and the elephant enjoy the water and see the giraffes, and see the zebra, see just thousands of birds and really enjoy the water, and the delight and brings it really to my heart. And what else? And we are seeing. So the local communities, and really, really grateful. And that was also a career defining moment when they said this: you have saved our lives and the livelihood. I think this is the best you can ever achieve in your life, particularly the impact as a water engineer and what you can achieve. So I'm so proud, and particularly I feel so much rewarded as a water engineer, be able to contribute not only in the UK, is globally for the society, global community, global society, and the environment. And so how proud I am, and for you as well, study water engineering. Your future is really great because they always need for water engineers. Otherwise, because in the world, either too much water, too little water, or poor quality of water. When the people's living standard increase, they want better waters. So the water engineers, you always have an important job to do to solve the problems, to bring the happiness. That's exactly like what the committee said to me and to the organization. You have saved our lives and the livelihood. And so that you are the future engineers and similar achieve the same thing. So to celebrate the success, we have written a book called The Return of Water. So now I want you to think about a question. Which is, how can we apply the lessons and for the future projects to ensure sustainable development and biodiversity conservation? So this story, you can see, and when they implemented in the 1970s, was a great success. But as time went along, realized further downstream, they have detrimental effect. So how are we going to design the project? Really consider all around, upstream, downstream, really ensure the sustainability for everywhere. So let me move on to the second story. That's about National Reservoir Inundation Mapping in the UK. So what happened, that was in 2000, a reservoir called Ali Reservoir. It's situated in the South Yorkshire, and that embankment was badly damaged after heavy rainfall. So that led to thousands residents downstream the dam being evacuated, and the M1 motorway, some of you might be through the M1, so being closed. So what's happened to that is not only that one reservoir, many reservoirs built in the same style, in the same time era. And in the UK, many reservoirs, we haven't been building reservoirs for decades. So many reservoirs are over 100 years old. So the government really, really worried what happened. Other reservoirs face the same situation. We don't know which community, which area we should evacuate, or how we can produce emergency response plan. So therefore, the government initiated a program called National Reservoir Inundation Program. So I was the technical lead and also the delivery manager for this program. So that's the challenge really enormous. So why I say it enormous? Because we need get the data, do the hydraulic analysis, do the modeling and mapping for over 2,000 reservoirs in the whole country. And the budget at that time is £2 million. So for all of you here in the university, you're good at math. So that means less than £1,000 to do one. £1,000 to do one. So you can work out how many hours you need to spend, just need to produce one. And the time frame to do it all is in less than 1 year. Just to compare how difficult, how challenging that was. And traditionally, if you use traditional method to produce one reservoir, do the study assessment, it takes half year. How much required? Typically would require about £10,000 to £20,000 per reservoir. So we literally only need, allowed for, spend 5% or 10% of the conventional method. That means if you use conventional method, we can't achieve it. So there's no budget, more budget available, particularly after the flood. Everywhere need budget. That's what the government required. That's need us, water engineers like you in the future, a different challenge with climate change and so many other challenges as well, and water pollution. So need you come out with innovative solution. So at the end, we developed basically a lean process. That's right from data collection and develop digital terrain models, do hydraulic analysis, produce hydrograph, and then to do hydraulic modeling and produce the maps, and then submit it. In the whole process, not only the one reservoir, you do simulate to the end, because reservoir, further downstream, there's another reservoir, and there's another reservoir. There's cascade reservoirs as well coming down. Then you can set it, how to trigger it, how to simulate it. So that is all what you learn, the fundamentals at that time. Because in order to work out the solution, you had to work based on really fundamentals. What you're learning in the university becomes really, really useful. So we be able to really deliver for it less than £1,000 per reservoir. So we literally made the seemingly impossible into possible. So of course, in the whole process, every step, there were innovations. So basically, for example, hydrology, new approach. In terms of modeling, advanced it further. And in terms of mapping, we come out with innovative method to do the mapping. And also the whole process is automated and standardized to achieve this result. Now, so what's the outcome? So we'll be able to deliver the flood maps and with also the travel time. When the flood peak is going to arrive or stop initially arrive a community, and when the peak is going to arrive with that information as well. And we're really, really proud to say we delivered this project on time and within budget. And before these exercises, this country simply there's no knowledge about the risk for the reservoirs. Now, after this program, we'll be able to close this map. Now, if you log onto the EA's website, you'll be able to see reservoir flood risk maps. So we'll be able, so proud as a water engineer, to close this knowledge gap, to equip the government and emergency responders. So with the information, they can respond this flood risk. And further to that, now the procedures we have developed not only helped us to deliver this program and also be adopted to deliver flood risk mapping in Scotland, and Ireland and in other countries as well. So that's become the industry best practices. So for the people sitting here, it's your future to help really break record, create more best practice in the future. So another question for you to really ponder, and what are your key takeaways from this National Reservoir Inundation Program? So next, I move on to the third story. This is about enhance the water quality in Welsh for 2 rivers. So there were 7 treatment plants discharged into 2 rivers, a 4 treatment plant discharged into Gwyndraith, and 3 treatment plants and discharged water into the Wylye. One is Gwyndraith, one the Wylye. And both rivers suffer poor water quality. Now, we've been tasked basically to find a solution. The client come up with the idea to build a new treatment work near the estuary. That's maybe on the screen, I don't know if you can see the triangle or not. So near the estuary, near the mouth of that. So the idea is basically to shut down the 7 treatment works, stop them discharging into the 2 rivers. Then they're going to use pipeline. The pipeline, that's a 30-kilometer pipeline to come in all the wastewater into the new plant. So that pipeline, because the length is going through over 3,000 private land. So that also going to go across some ecologically sensitive area as well. So when we take on these projects, so I'm the technical lead, and particularly for the water quality side. So we actually challenged about this brief. So are there any better ways to do that and avoid the pipeline going through so many private land through those ecologically sensitive area? So we come up with a solution that's again based on fundamentals you learned in the university, the basic fundamentals, hydraulics, the link water quality. Then we'll be able to come with a solution through the hydrodynamic assessment of the whole system in the catchment. We come up with a solution. You'll be able to really tighten the phosphorus reduction in 2 treatment works. One is measured on the Wylye, one is measured on the Gwyndraith. Then combined with catchment approach called fair share, we'll be able to achieve good water quality to excellent water quality in the river. So by doing that, what we have avoided, we eliminated the need to have the 30 kilometers pipeline. So we avoided to going through the 3,000 land parcel. So furthermore that, and the capital cost we saved is 75%. So the exact figure is £60 million. So original total scheme, the capital cost is £83 million. We'll be able to save £60 million. So further to that, we also work out the whole life carbon. We'll be able to save 78%. That's 100,000 tons CO2 be reduced to emit to the atmosphere. Just to give you the concept, what that's equivalent to. So that's equivalent to 20,000 cars be removed from the road. So we achieved a number of firsts. Maybe I just want to mention one. For this, we basically considered, for the first time for the scheme, to consider the catchment approach and also whole life carbon as well. There are other firsts I'm not going to dwell here because of time constraint. So what's the recognition we have got is also really rewarding. So we achieved the Technical Project Excellence Award for outstanding contribution and innovation from our client, that's Welsh Water. And within the company, we have got 1 Mott MacDonald award. So that award is chosen by colleagues. So we have 20,000 colleagues in Mott MacDonald. So this project was chosen as the Staff Choice Award. So even further, so some of you maybe will become a chartered civil engineer in the future. So this project is featured in the ICE, that's Institute of Civil Engineering, the State of the Nation report, this flagship report, only published once a year, is featured as a best practice for innovation and the lower carbon. So study water engineer, so everything you see from this story, you can see I'm so felt so energized every day to be a water engineer. Now, another question I would encourage each one of you to think, because some of you will go to industry, some because continue to be the researchers. So how can researchers develop sustainable and innovative solutions for the global water quality issues? So this is in Welsh. We globally, because so many similar or different type of water quality problems, we need the young future generation professionals to help to solve that. Let's come on to the fourth story. The fourth story is about the coastal flood risk, and in 2013. So for some of you might be very young to remember, and certainly the professors sitting here would vividly remember the situation. In December 2013, UK experienced one of the largest coastal flooding since the infamous 1953 flood. So this is the thing we have seen, it's been in the news, and so particularly along the east coast, Humber was the worst hit. It's basically the tide level and get to 5.8 meters AOD, and it's really break the record. So that's the thing on the right side. You can the water on the street is the river. The street is like a river, and the wave. And if you look at the news, what said is 20 foot, and wave really hitting the towns. Many towns as well. And this. Also the picture you see across the country, we got helicopters because everywhere is flooded, not accessible, and use helicopter to drop the sandbags and materials to close the bridge because the wave and the water is so powerful and create this damage to our defense and infrastructures. So you can see this so badly. And what's happened also, and along Humber and along the east coast, people's home be flooded. And the rescue team work tirelessly day and night. That's during from the 5th of December to the 7th of December in 2013. And the people's life simply turned upside down. Imagine you are a water engineer. What can you do to help to reduce the suffering, the misery of the people? So that event happened on the 5th and the last to the 7th of December. And the Humber bank being badly damaged and eroded is different from before. So we've been commissioned by the Environment Agency to predict, to predict what the flood and to the communities, why they want us to predict the flood. After this flood, even further bad news were received. One bad news is there was high tide forecasted at the beginning of January 2014. Seems there's no time to repair the damaged flood defense. And another high tide and forecasted end of January 2014. So therefore, Environment Agency quick took action, commissioned Mott MacDonald to basically to predict what the flood risk to the communities with the eroded, damaged flood embankment. So the deadline is 31st of December because the high tide they predicted beginning of January 2014. They have to know and who they need to inform to evacuate, what emergency plan they need to develop. So literally that's 2 weeks. And what also got this in between and is Christmas time. Now we literally race against time and race against tide. So how are we going to solve this problem and produce the result and do the planning, do the emergency evacuation? And we have developed in-house called water and wave overtopping tool, be quickly simulate and predict the overtopping rate for different types of the defense. Then we coupled with hydrodynamic models, be able to predict where flood will be spreading. So we be able to deliver the flood maps and risk, and to see who and where, including infrastructures, will be affected to our client by the 31st of December. So that means that year I did work through Christmas time. But that is really meaningful. That you found that is what is about here. Do something useful for the society. There's something we've been trained for. They really need your skills. So proud and to be able to do that. So what have we achieved? We actually be able to win the race against time, against tide, and also deliver the information to the client. The client produce the plan, and they make the public prepared. If they're prepared, then you know what to do. And the client was really happy with the overall process and what's been delivered as well. So this fourth story. Move on to the fifth story. That's about developing water pollution reduction performance guideline for Water UK. So why this necessary? And this is not only necessary, this is very important. This is really crucial because in the UK, and particularly England, we have bad water quality. Just to show you some figures, recent figure shows only 14% of the rivers are not achieving good ecological status, and 0 river. How sad this is. As water engineers, we must do something. So 0 rivers achieved a good chemical status. And you may be wondering where those pollutants come from. So basically they come from 2 sources. One is point sources, one is diffuse sources. The points is largely from agricultural land. They contribute 40% of the pollutant load and 36% from the wastewater, and 18% and from the transportation and urban area. The remaining 6% is from other sectors. So now we've been tasked and to develop the guideline. We thought this is very much our roadmap to develop the guideline. I think it's so important involve the leadership right at the beginning to develop vision. So what we have done? First, we involve CEOs or high levels from water companies. We all in the same room, and the same roof develop the vision. So we need a vision to drive us and forward. And then we define the theme, what area we should focus on, what theme should be, how to make it simple, and also the actions. And if you develop theme, what actions within each theme, and what outcome you would expect. So for this, the vision we develop is this: sustainable and healthy environment with no impact from water pollution. So this can't be solved overnight. So for you will come into the workforce, coming into industry very soon. So you have this duty as well to basically help us, the nation, to achieve good water quality. So early on, I talked about the percentage. So agriculture and wastewater, similar contribution and in terms of pollution load to water. Because storm overflows been made the headline, so it become hot topic, I thought it's better to share some of the facts and figures with you. And hopefully it's inject with some energy, the desire for you to study even harder to become useful in the future. So we have in England itself, we got 15,000 storm overflows. And in the bracket is the UK, the whole UK figure. So they discharge 40,000 times a year. And how long it lasts? 3 million. You can do the calculation, how many years is equivalent to for 3 million hours discharged into the different water bodies. Just look at the CSOs, slightly from a slightly different angle. So in the UK, so we talk about in England, we got 90% of CSOs discharged at least once a year. And we got 5% discharged more than 100 times. More than 100 times. How many days do I have? A year. More than 100 times a year. And how about the average number? The average number is about 29 times a year. And on average, per CSO discharge, 7 hours. How many hours you study? so per day. So you can imagine how many hours and the water being pumped into our system and where you're passing. And here, I walked here this morning, passing a brook as well. And some people maybe enjoy open water swim as well. So there are 80% of the CSOs and discharge near the bathing water. So you know what's the danger is swim in the water if it's heavy raw sewage. E. coli is particularly damaging to your health. So this is the CSO numbers. So when we developed the guideline, and we also interviewed water company staff, and basically try to have a good understanding about the root causes of those assets linked with the CSO spills. So this is the common feedback from different water companies, colleagues, from manager level to operational managers to their staff. Blockage. Blockage, who caused the blockage? Is a lot due to the public, the misuse of our sewer network, the asset failure, and also due to construction, different things, road work, everything else, cause asset failure. Then also power outage, because a lot is some of the treatment plant, everything else, may be built in the floodplain, and all the substations built in the floodplain. When they're out of power, that will affect all the pumping station as well. So also the main pipe burst, and the sewage will also discharge it out. And also for every project, if human involved, there's human error as well. So this is the picture you see, how sad it is. It's not water company themselves is get the raw material there in terms of white pipe. White pipe is one of the key things, is misuse and cause the blockage. So I think things I would encourage you, your friends, your families, wherever you can, and educating other students in junior school, primary school, or secondary school about how to use our facility in a most responsible way. Stop have the wet wipes and to chuck into the toilet. So all this, you can see the sewage, outpourage, and also the pipe burst, and the human error. Human error is often cascade, is like Swiss cheese. So for us, whether in the future, what level you are at, make sure we try to minimize our human errors as much as possible. One the way to do it, become competent, high performer. If you're not competent, if you design, and could lead to failure as well. So the themes we divide into 4 areas. We try to make it simple. One area is called way of working, and the second area is data, because we need to be evidence-driven. The third area is we have to look at the asset, because the asset itself is contribute to a lot of things, and also can make a lot of things work, and also can make things not work. And then I think the last one, particularly relevant to researchers, to improve the scientific understanding. So you can help us, basically help the industry to improve the scientific understanding. So for each theme areas, we have different actions. We have the first tier of actions. Within that tier, we subdivide into different tiers. Due to time constraints, I'm not going to go through all different tiers to it and link with the outcome. Some maybe you can't really read because the words are too small, but at least you can get the flavor, the way of this. I highlight the key words. Collaboration is absolutely key. We can't work in silo. What company have to work collaboratively together with industry, with consultants, with academia. We all together, and with the public as well. And secondly, is about we have to adopt best practice. Different water companies are already developing different best practice. We need to learn that, share that across the industry for the sake of our environment. And also, we have to engage the stakeholder, because the source of the water, wastewater discharge, is from every individual, you and me and the general public. And also we need to educate the public to make it really responsible. So this is the way of the working. So what is the second area of the theme? Data. So that's again, top layers is 4 areas. So we must have a data-driven strategy in order to make a difference. And secondly, we need to have support tools. The tools have to be effective. And thirdly, data has to be open. You can see before you wouldn't know how often, how much, how long the CS spill, and because once the data become public, now the public understands, then the huge investment is going to be made in the next AMP until 2050 to what company really determined to sort out the problem as well. And also link data with the pollution incident as well. So the data, so the lot, so whether you do data science or collecting the data is so powerful. The third theme is to do with assets. So assets, we need to reduce the CSO spills, not only frequency, also the volume. And secondly, we have to improve the storm management, how to reduce the total amount of the water getting into our pipes. So by have some green infrastructures and also slow down how to store the water as well. We have to improve our infrastructure, not only the conventional method, engineering, we have to think about green infrastructure as well. And then lastly, we have to use data, because if we're going to use natural-based solution, we have to use the data to tell us, because this is a relatively new area, to learn how effective, when, how long, what do we need to do. And so this we need to collect data for improve the future performance for our asset. And then lastly, that's really close to the academia, to that. So I'm a wholehearted support. We need investment. We need investment in R&D, in technology, in the treatment process. And I'm so pleased and walk through here. We got one of the research center at the building, dedicated building to help to do focus on water and the pollution and the environment. And we also have the long-term monitoring. So that's so important to see our investment, where is cost very effective. And we need better tools, better models. So when you're learning and some courses in the university, so when you come to interview in the industry, so we will say what fundamentals you learned, what tools you already learned. So you eventually become somebody, it's not for the sake of the exam, get a result. You basically to solve the real problems. So how can we develop better tools, better models in order to solve the real problems? And again, I emphasize the word, improve the monitoring, because the public need evidence, your research need evidence. For us, when you see that improve and we need evidence as well. So I'm not going to go through the outcome and other layers of actions. So I would like to invite every one of you in this room to really think about, because everybody will contribute to the CSOs, so how can we address the root cause of CSO spills? So this comes to my last story, the sixth story, is about water supply in Shanghai. Shanghai is situated along the east coast of China, is next to the, well, you can see from the map, got East Sea, is also at the mouth of the River Yangtze. River Yangtze is the largest river in China, is also the third largest in the world. So in Shanghai, it has a lot of challenges in terms of water supply. So the characteristics of water supply in Shanghai, the challenges, I think I can summarize in 3 words. So what are the 3 words? One is old, large, and difficult. Why do I say it's old? Because we know in this country, a lot of assets built in Victorian time. In Shanghai, it's an old city. So a lot is built over 140 years old. And large, because areas covered is large, and the population, if your population exists, you need industry, you need a commercial. So that 30 million to any, in the UK, we don't have 30 million in any city. So they're also difficult because the speed of change. So many of you students sitting here maybe is definitely less than 30 years old. The professors is more than 30 years old. So the speed of change just in my lifetime, just simply from 1994, the population in Shanghai is 13.5 million. So it's more than in London. What is now is about 30 million. It's more than 3 times the population in Shanghai. So within 30 years, with such a speed change of population and the infrastructure, everything else, and the business, everything will need water. That's everywhere. So there's business people need to exist, need water. So where are they going to get this water, and so fast? You can see where it's located, along the east coast, coastline. So if you try to get groundwater, they got millions of high-rise buildings. It's not a good idea because it can cause another risk of the settlement that could put people's life, infrastructures at risk. And you say, okay, near the sea, maybe we can use desalination. But that is not huge costly. That's not environment friendly, and it's a lot of carbon and it's going to be super expensive as well. Now there is always ask yourself the question, what else? What else? Because these words never going to be out of date. You always ask this question, what else? They come up with innovative solution, and for this actual problem to supply the water, such big population and such fast change. So on Earth, it's very rare you can have such big change. Basically, now they are at the mouth of the River Yangtze. River Yangtze, the base flow about 10,000 cubic meter per second. So there's a little island, and in the River Yangtze. Now they thought about our idea, build a reservoir at the mouth in the middle of the River Yangtze. Yes, what you hear is correct. It's built in the middle of the River Yangtze. So the concept many people have, and when we're teaching students as well, reservoir, most will be built in the upper catchment, not at the mouth of the river, in the middle of the river. Yes, it's built in the middle of the river in 2010. So what's the dimension of the reservoir? So I have Googled before came over here about the size of the whole hectare. The entire area, and for the reservoir surface area is 70 kilometers, is 1.5 times of entire hectare. I don't know every student, you have to covered every square inch of the hectare. So this covers 1.5 times. So anybody run marathon here? Has run marathon or plan to run marathon? Okay, so this embankment length for the reservoir alone is 48 kilometers. It's longer than the marathon distance. So you can imagine if you're starting, you still haven't finished, gone through one loop yet. And it can supply to 60% of the population in Shanghai. So you may be wondering, how does that work? So basically, I show here the outlet, where it is, and also there's inlet. The inlet, there are 5 sluice gates. So basically, when the tide drop, and then the fresh water flow, before it's lost into the sea, they capture it, let it flow into the reservoir. And then when the tide come, they shut the gate and stop seawater get into it. And so when the water is stored in the reservoir, they also have the outlet sluice gate. That's for, should an event happen, you always need to build resilience. You can't just one way in, there's no way out. So they have an outlet, be able to flush out the system as well. So when the water in the reservoir, so they have 2 twin pipes, so underneath the river and come onto the land side and to be treated. How big the pipe? So it's basically is nearly 6 meters. It's 5.84 meters. It's like 4 of me step on my shoulders. That high is diameter of the pipe, and 2 of them. So we come to the land. What's happened to it? They have a 13 treatment plant. Treat the water coming from the reservoir before they distribute it for the population. So that is really outside the box thinking. When you come to the end, there's always a solution. So what it is done is when water engineers have to be really creative. So in England, particularly in the southeast of England, we have challenge as well. So what the challenge we have got, what particular water resources, water supply. You maybe turn the taps here on, you got water. What is the challenge we face, particularly in the southeast, is particular prediction. There won't be enough water to supply to the people to support their lifestyle, and there are also population growth combined with, coupled with climate change. So then there will be water shortage. So I would encourage you to think this question: what can we learn from a Shanghai water solution to address our challenges in southeast England? And a lot of you will come into the industry very soon, so you will, maybe, if you study water engineering, and come to this situation, at least use water. Currently, there are a number of reservoirs being planned, like Links Reservoir, Fence Reservoir, and the Thames Reservoir, and the in Wessex Water, Mandeep Reservoir. Those things being planned. But I would really encourage you to think about how can we learn from this story. So that's come to the end of my talk. To conclude, so now I have explained 6 stories. That's all based on my own experience because I involved in all those projects. So these 6 stories, what's really in common? I think they all highlight the power of innovation, innovative thinking, and resilience in overcoming challenges. They're seemingly impossible. So because this session we got students here, I'd like to pose further questions to you. How can we apply these lessons to our own situation and research? And the last question is, basically, what's your takeaways from this story? So that's the end of my talk. Thank you very much, everyone.
Thank you, Sun-Yan. It's very inspiring talk. You talk about showing so many stories. Yes. Any questions? On top.
Thank you very much for the great talk. So in the project you introduced, you used and developed, computer models. I wonder, have you ever used machine learning, in your project over the years? And what kind of, application areas? So, have, the machine learning been used?
Yes, and as a company, we use machine learning in various areas. Personally, I use machine learning in 2 aspects. And one in particular to do with coastal forecasting. So some of you, if you're interested in news, that you may heard called Boston Barrier. So that is the largest coastal projects in the UK. So I was involved in the whole process from the modeling to the public inquiry and to later on the construction phase of that. So when the barrier was built, then we need to know how to operate because it's built is near the wash as on the haven. You got tide, you got tide, you got surge, and then you all got river coming down and river with them coming down, the flow coming down. How are you going to operate the barrier to stop the flooding with a huge investment, over 100 million being invested on that. So we used different method. It's a 5 conventional method because it's important to get it right. 5 conventional method, and another 6th method, also the machine learning method, because the method I use is very much use a tiered approach, because the tide, astronomical tide, is very easy to predict. How you can build tide, surge, wave, and wind into all the prediction using machine learning. I think basically for us in this era, and it's must have technology you need to use what can benefit us as human beings, and particularly for the society, for the environment. So the answer is yes. Yeah.
Thank you.
Yes. I have a question about the last story.
Yes.
We usually build a reservoir upstream of the river to avoid water quality, contamination. And how do you address the water quality? And other question is, since this is close to the East Sea, so how could you solve the problem with seawater intrusion? And lastly, I think since there is a lot high level of tidal difference, you can also build a tidal power plant that intake of the reservoir?
Yeah, okay. The three questions, let me just answer one by one. One is water quality. Normally, if you're upstream and it's better downstream, sometimes overseas work, we say downstream is like people's toilet because everything discharged into there. Now, River Yangtze at that location is about 90 kilometers wide. So why they not built is along the edge. They did build some along the edge. Tend to be along the edge, you have poor water quality because different cities along the line cause bad water quality. But tend to be in the middle has better water quality. That's why they choose that location. So it's not possible for them to choose further upstream to transfer it, go through so many pipelines. It's not feasible. And for other smaller regions, they do have over 2,000 smaller streams around Shanghai, but those, because construction and development in that area, their quality much poorer than the River Yangtze. So that's why they choose that location, because better water quality. That's why they build it in the middle. So the second question relates to now, how about sea line intrusion? Because the seawater get into it. So you do have that risk, but for normal city, when they design, because the fluvial flow is very big, so it's important upstream use water responsibly, not stop it. So we need a really strong current to push the tide out. So when the tide really low, so then you got fresh water coming. So there's no seawater. So the timing is so important. When it's fresh water, when there's no seawater. So they'll be coming in that window very closely. So in addition to the 5 sluice gates, they also get pumping station as well to help them pump fresh water into it. So therefore, that's the way they try to, before the tide rise, they close it. Yeah, so that's the avoid the second sea line. So basically they're well tested to have that scheme. So third one about, you talked about tidal scheme? Cover public, okay. The tide range in that area is not that big constantly. It's not like the Bristol and the Avon. So the tide range, and if you look at the changes over there, it's not so huge. I think there are other means in Shanghai to try use wind and solar and the other means for the electricity. Yes, they're all interdependent, water, electricity, so we just rely on them. Yeah, good question, thank you.
Thank you very much. I'm afraid because people for next hour they're waiting outside, so I'm afraid we have to close today's session. And so thank you very much for coming to listen to Samian's talk. And could you please join me to thank Samian again? And next week our seminar will be on Monday, 9:30 in Crew Building. So please do join us in next week. Thank you.